Hello and welcome to NEET Physics Ninja. Today we are going to solve a problem related to dimensions, particularly dimensional analysis. And we're going to look at how we can figure out the dimensions of certain unknown quantities in an equation. For this, we're going to use what is known as the principle of homogeneity of dimensions. So according to the principle of homogeneity of dimensions, in any equation, each term will have the same dimensions as all the other terms in that equation. For example, if we have a very simple equation like F equals ma, what the principle says is that the dimensions of the force F on the left side should be the same as the dimensions of this product m into a, mass times acceleration. So this is a very simple case where you have just two terms, but if you have more than two terms, let's take another familiar equation. The equation of motion S equals ut plus half at squared. Here the dimensions of the term on the left side of the equation must be the same as the dimensions of the first term on the right side, and same as the dimensions of at squared, the second term on the right side. The half, of course, is dimensionless. It's a pure number, so it doesn't participate in the dimensional analysis. So this is what the principle of homogeneity of dimensions says. In simple words, it says that you cannot add apples to oranges. The dimensions, if you're equating or adding or even subtracting two quantities, you must make sure firstly that they're all of the same dimensions. For example, it's meaningless to ask what is 1 meter plus 1 second. Right? It's a completely meaningless thing. So you cannot add or subtract or even equate quantities that have different dimensions. In order to equate them or add or subtract, their dimensions must match. Alright, so keeping this background in mind, let's look at this problem. We are given that the velocity v of a particle at time t is given by this particular expression. So I'll write down that expression, the equation in fact, down here. And we are asked to find the dimensions of a, b and c. Now a, b and c are unknown quantities. We don't really know what they are. You don't have to think that A stands for acceleration necessarily or B stands for something else. Right now we're going to treat them as unknown constants. Okay, and now our job is to figure out what the dimensions of these are. Firstly, we can see here that the dimensions of C are quite obvious, because if you see what's right next to C in the denominator, we have this combination T plus C right here. And as I just mentioned, according to principle of homogeneity of dimensions, you can perform such an addition only if the dimensions of C are the same as the dimensions of T. T being time. So what we expect here is the dimensions of C should match with dimensions of T. And t is time, which means it has dimensions of time. So right away we know what are the dimensions of C. Whereas to figure out the dimensions of B and A, we have to do a little bit more of calculation. So what we'll do is, firstly, let's say we want to figure out what are the dimensions of B. So we expect from principle of homogeneity of dimensions that dimensions of V on the left side should be the same as the dimensions of B by T plus C. Correct? So these are two terms Of the three terms, we are considering two terms, one from the left side and the second one on the right side. The dimension should match. Now dimensions of v being velocity, as it's mentioned in the question, are lt minus 1. And then you have dimensions of b divided by, now the denominator, as we've just seen, is time. It is t added to c also having the same dimensions as time, so it's basically t. So all that remains is for you to cross multiply lt minus 1 times t, which is lt minus 1 plus 1, which just becomes lt0 or just L. That means B has the dimensions of length. And finally, we need to figure out the dimensions of A. So to find the dimensions of the constant A, we are again going to use the principle of homogeneity, but this time let's equate the term on the left side, velocity, to the first term on the right side. These dimensions should also match according to the principle of homogeneity of dimensions. And so this will be the product of dimensions of A times dimensions of time, t. But we know what are these dimensions. We know dimensions of velocity, it is lt minus 1. And dimensions of A, something we are trying to find. And dimensions of time is t. So cross multiplying, we get lt minus 1 by t, which is lt minus 2, which basically comes from minus 1 minus 1. You take the t in the denominator up, and you get lt minus 2, which happens to be the dimensions of acceleration indeed, but that's not obvious from the question, because there can be situations where A could refer to any random constant, not necessarily acceleration. But in this particular problem, it happens to be acceleration. So we have found the dimensions of all three quantities, all three constants. So we have C right here, dimensions of time. B has dimensions of length, whereas A has dimensions of acceleration, lt to the minus 2. And if you look at the options, there's only one option that lists them in this order. Observe carefully that in the question they have mentioned A, B, and C in order. So the options would also have the dimensions in the same order, with the dimensions of A being first, followed by dimensions of B, and finally the dimensions of C. And the correct option, as you can clearly see, is option B. So B here happens to have the right dimensions of A, which is lt minus 2, B, which is L, and C, which is T. So you can go with option B. Now, one thing to note here is that if this was a question in a competitive exam where time is of essence, you don't necessarily have to calculate all three dimensions of A, B, and C. The moment we found that C has dimensions of time, and we know that the dimensions of C are mentioned in these options at the end, the last one. And when you look at the other options, you can see that no other option has T as the dimensions of C. And so right away you can go with option B, just after having found the dimensions of C. That's a big time saver, because since you found the right answer, right option, by just looking at dimensions of C, it's not necessary to check for dimensions of A and B as well. If the question is right, it has been framed rightly, and the options have been put or have been designed correctly, option B has to be the correct option, because at least A, C, and D are not, right? So you're ruling out A, C, and D on the grounds that they show the wrong dimensions of C, and so based on that you can go with option B. But here, since we're learning how to go about solving such problems, I've shown you how we can find the dimensions of all three constants A, B, and C. It's also important to note that once you have understood this, it might have been possible that there might have been one more option that also showed the dimensions of C to be T. in which case you would have to find the dimensions of at least one more constant, right? Either B or A or even both. Here we happen to be lucky because there's only one option that has the right dimensions of C, and C being the easiest one to find the dimensions of. So that's it for today. I'll see you in the next problem.